The easiest way to explain Ark is that it's an on-chain batching mechanism, meaning that you have a single on-chain Bitcoin transaction with one output, basically a claim to multiple people's ownership of Bitcoin. Our system is a bit more non-biased towards the purpose of what you're doing, how you're transacting. If you wanted to do a multisig on Bitcoin, you can do it in Arkade. If you wanted to do time logs and hash log contracts, you can do it. We want to do a general purpose off-chain environment.
Hey everybody, I'm Shinobi from Bitcoin Magazine, joined by Mr. Kukks from Ark Labs, and we are here today to talk a little bit about Ark and Arkade. So, depending on the order these get published, viewers might have already seen a talk with Matthew Vuk from Second. So, just to kind of compress a little bit, you want to give like a short TLDR of what Ark is?
Yeah.
Just at a basic level, and then we can move to Arkade and like what you guys are doing specifically.
Yeah. So let's talk about Ark. The easiest way to explain Ark is that it's an on-chain batching mechanism, meaning that you have a single on-chain Bitcoin transaction with one output, and this output is what we call a batch. And this batch is basically a claim to multiple people's ownership of Bitcoin. Essentially, if you have four people that have 0.25 Bitcoin each, the output would be 1 Bitcoin, and then from that point, from that on-chain output, you would have a series of pre-signed transactions that kind of deliver each one's claim, which we call VTXOs.
All right, and how exactly does kind of the batch creation process and like actually transferring those VUTXOs work?
Batch creation process is kind of a coordination process. People show up with their, whether it's boarding UTXOs, basically their own on-chain Bitcoin, or whether they have existing VTXOs that they would like to renew or settle. They show up, they register an intent with the Arkade operator. The Arkade operator will group these intents by users together and then start a coordination process, which we call a session, batch session. They will essentially construct the tree, the virtual transaction tree together, and the on-chain transaction as well. If you're bringing your own UTXOs, that means you add them as an input to the transaction. If you're bringing existing VTXOs in the Ark system, you create this thing called the forfeit transaction. And the forfeit transaction is basically, the easiest way to look at it is like an atomic swap between your existing VTXO for a new one in the new batch, using this thing called a connector output. But I won't get into that.
Okay, and so like the general idea is essentially like a way to transfer coins off-chain in a similar way to Lightning, but rather than having to create like a bilateral relationship with a specific person, anyone willing to interact with the coordinator is somebody that you can just freely transfer that to.
If you look at the core Ark protocol in itself, it's really just an on-chain way to group people together in one output. What you do after that, if you want to do transfers between people off-chain, that's a whole different section of the whole system, which we call the virtual mempool, where essentially you have VTXOs. VTXOs are really just a series of unbroadcasted Bitcoin transactions. So any VTXO can really become a UTXO. And if you want to transfer your VTXO, or you want to do a transaction that does whatever, sending money back to yourself, splitting up some values, paying multiple people, a normal Bitcoin transaction kind of thing, you just create a real Bitcoin transaction. You sign it, you send it to the operator who co-signs it as well, and sends it back to the user. And now you've just created new VTXOs and you burnt your old VTXOs. Okay.
And so you guys have kind of gone a very different direction than Second with your Arkade system. And the goal is to, rather than just be a payment processing system, like actually allow kind of a flexible programmability for what users are doing with their money. You kind of want to give us like a broad overview of like the architecture here and like how this actually works?
I think the biggest difference is that our system is a bit more non-biased towards the purpose of what you're doing, how you're transacting. Just like on Bitcoin, we want you to be able to express your own unlocking scripts. Essentially, like if you wanted to do a multisig on Bitcoin, you can do it in Arkade. If you wanted to do time logs and hash log contracts, you can do it. And it's an open system. That's the whole purpose there that we're going with. We want to do a general purpose off-chain environment. So most of the things you can do on Bitcoin, you can do in Arkade. And I would say the biggest differentiator there is we don't build in opinionated rails. So in terms of, for example, Lightning, we don't have it built into Arkade. Instead, we delegate it to other external swap providers. It's an open market as well, by the way. So anyone can just come in and start offering a swap service with Lightning or with on-chain or with USDT on other chains or networks, which is what's happening today is already.
I have directed Secretary Connolly to suspend temporarily the convertibility of the dollar into gold.
I know this isn't really kind of in like a polished or deployed like final state, but part of the game plan with like this programmability is to extend a little bit beyond what the actual base layer of Bitcoin can support right now. Like, how does that functionality work? Like the enforcement, what's the trust model the users kind of have to opt into for that type of functionality?
Yeah, so it's still early days. We're still working on an early preview, which we aim to ship within the next month or two. Essentially what we're doing is we're offering yet another cosigner service that will not just blind cosign based on the VTXO state to prevent double spends, but also allowing you to express additional constraints on your VTXOs, on your scripts. And these constraints are basically using an additional Bitcoin script interpreter with extended opcodes. So quite a lot of different opcodes, full introspection, so input introspection, output introspection, amounts, 64-bit arithmetic, all the stuff that people have been kind of begging for years. The team has had a lot of experience on building these kind of things on Liquid previously, so we know what to expect and what people are expecting to be able to build interesting and new novel things for Bitcoin. Then there's also, I guess the main thing that you're asking for is the trust assumption there. It's a cosigner service, so you are relying on it to be able to execute it in an honest way. For us, what we're doing is basically all our cosigning services or sensitive services will be running in a T. At the very least. So at least users can have a verifiable honesty. Yeah,
so like a trusted execution environment.
Yeah, exactly.
Like an enclave to actually guarantee that it's running the code that it claims it is.
Yeah, we're building a framework, an enclave framework, so that all our components of Ark is getting separated into these different solutions, different software, and we package them up as enclaves, and we deploy them to production that way. When you hit the service, you'll be able to actually get a digital attestation that tells you that this software is running this specific version, and you can go back and obviously everything we build is open source and MIT license, so you can go verify that, do a reproducible build yourself, check that there's no backdoors or malicious code in there that can give us basically bad access to the software or fake signatures or whatever. And users can at least have this verifiable honesty. Additionally, we also envision to have this service, this co-signing service for the opcodes, to be also self-deployable by users. So if you're a business that is running, that is planning to use Arkade script, which is what we're calling these opcodes, if you're planning to use Arkade script, you can run the service yourself alongside ours. So that way, when we are running the Arkade script on our side, you also run it to cross-verify, so that we don't sign things that you wouldn't sign in the other way too.
So like pretty much completely removing the possibility of like incorrect execution if you choose to run one of these signers yourself.
Yeah, exactly. The whole point is that it is a trust-based service, right? So at the very least, we want to offer something that people can verify that we are running what we say we're running, and that people can actually verify true code, open source code.
Well, I mean, if that's open like that, then that sounds like something you could very quickly see like a marketplace develop around, or possibly federations or different actors that you could kind of choose on like a contract to contract basis, depending on who you're interacting with, like who both of you trust in common and things like that.
Yeah, you could definitely do it that way. You can even have a series of combination of things. So you can have a cosigner that has a Frost federation behind it. You can have multiple different horizontal scaling of these cosigners running at the same time, so you add them as part of the check sig. You can have people will be posting, for example, every time you do a transaction with an Arkade script, you have to publish the script and the witness so that anyone can run it locally and verify that it's an honest execution, that nothing got messed up there. I think we'll see plenty of different combinations of what works best for users.
Yeah, so like even contracts you aren't directly a party to, like if they're executed incorrectly, users can see that and note like this co-signer is untrustworthy, don't use him.
Yeah, exactly. You can, I mean, we're going to be enforcing it so that everyone that is running this co-signer will also have to run it in an enclave as well, at the very least, so that at least you don't have to, trust this specific user to be honest and this one not. And if you have a contract and you build an Ark address, the signature requirements from a public key will always be tied to specific operators, right? To specific cosigners. So you don't want to have somebody rug you midway through a contract, because then you'll get stuck. So we'll enforce, at least we'll do our best to enforce enclave usage for these things. And also make sure that people will be running fallback mechanisms.
I mean, this sounds like a very different project from what Second's building. So
yeah,
I hope we see some interesting things built with it.
Yeah, for sure. I feel like we're in a good state now. We've been experimenting a bit with different smart contracts that we want to do. One of the quick wins that we're going to get with this is offline receive with Lightning. For swaps, at least. Essentially, you take an HDLC and you add an extra spin path. And instead of having the receiver signature check, you just have the pre-image hash lock unlock. And you'll have a covenant that says the money has to go to this specific user, and this amount has to go to this specific user, so that anyone else that has access to the pre-image will be able to just claim the money on this user's behalf and just send it over.
Okay, that's very promising.
Yeah.
Well, I'm looking forward to playing with it when you guys drop it in a month or two.
Yeah.
All right, well, I hope everybody learns some interesting things about the new toys we'll have to play with soon. And thanks for sitting down with me.
Yeah, thank you.
Take care, everyone.